We're going to continue now learning about scores and take a closer look at how to represent chords. Uh, First of all, just a few thoughts about scores now that you've seen them. Why do scores have keyword parameters? Why are we using this Lisp notation? How did we come up with this? Scores fill a very interesting position in that they are both data and programs. They're data in the sense that you can manipulate them quite easily. You can transpose, you can stretch, you can select things as a data structure, and you can also generate scores as data using algorithmic composition techniques that we'll learn about. So scores play a pretty valuable role. They were not in the original version of Nyquist, but over time it seemed that expressing everything directly as a program was not always the most effective way to work with music and music data. On the other hand, scores are programs. They have a well-defined semantic. They are extensible through adding attributes and by making function definitions. So they play an interesting kind of middle ground between programs and data. And I think that's the real advantage. There's a special case in scores that I want to tell you about. That's how to represent chords. Here's an example of an event from a score. Time 3, duration 0.7. The instrument is a note. But look at the pitch parameter. Instead of being a simple expression and a number, it's a list of numbers. And whenever the score processor sees a list in the pitch attribute, the sound event is effectively expanded into individual events. So this first sound event up here with a list of pitches is equivalent to 3 sound events, one for each of the pitches in the list. Notice that all the other parameters are duplicated, and also note that this only works for the pitch. So if I provided a list of velocity parameters, none of this duplication would happen and the program probably would not work. How do we turn scores into sound? We call this rendering. And the function to do score rendering is called timed seq, short for timed sequence. So the function name is referring to the fact that the score is really a sequence of sound events with times, and that's what timed seq expects. So this timed seq returns a sound, and because of that, you can apply timed seq to a score, take the sound that comes back and pass it into a filter, pass it into a reverberator, other unit generators. So it's a very general system. On the other hand, if you want to just play the score immediately, there's a function called score play, which you can execute. It does not return a sound. It actually invokes the play command. It internally uses timed seq to do the conversion. So you can use score play, but generally you just use it exactly like this. At the top level, do an exec of score play.